Okay, so let's take a look at page 31. We're going to do some factoring practice problems. We looked at GCS and grouping last week, and we're going to take a look at trinomials. That was your last homework video. We're going to take a look at some trinomial practice problems for today. So let's start with the first example on page 31, x squared plus 9x plus 14. I'm actually going to grab some scratch paper as we're working today, just because there's not a lot of room to be able to do work on page 31. So I'm going to use some scratch paper. So when I have three terms, there were two strategies that you saw in that video. One of them was what I call guess and check, and that's primarily what we used in Algebra 1. We're looking for factors of this C term, our constant term, that add to D, our coefficient on the X term. And then I also showed you how we can rewrite these three-term problems as a four-term problem and use our grouping strategy. When my lead coefficient is 1, guess and check is a good option. If my lead coefficient is anything other than 1, like the next few examples, my personal preference is to use AC method. It tends to be a little bit faster process for many of us because the order in which I rewrite those middle terms doesn't matter. So I don't have to go through the guess and check process of distributing. Did I put these factors in the right place? Did I pick the right ones? If it doesn't distribute correctly, I have to move things around. So I personally like AC method if I've got something like this problem, but guess and check works really well for something like this. So that's what I'm going to use here. If you have a preference and you want to see me do a problem a different way using the other strategy, then just ask and I'm happy to do that. For this guy though, since our lead coefficient is 1, I'm going to use that guess and check method. So I'm looking for factors of 14 that would add to 9. I talked about this in Algebra 1, so those of you who had me for Algebra 1, this will probably sound familiar, but for some people, it's like the numbers are already written on the page for them. That's how fast they come up with the factors they need, and that's great. For some of us, like we got to write it down. We got to make a list, and that's fine too. Does anybody see what factors of 14 you need to get to 9? 7 and 2. Yep, I want 7 and 2. So this would factor into x plus 7 times x plus 2. If I had swapped my numbers here, I would have the same factors just in a different order, and that's okay. Remember, the goal is that when I distribute this back, I would have x squared plus 2x plus 7x plus 14. And if I combine my like terms here, I end up with the original problem. That's always the goal when we're factoring, is that if I distribute, I get back to the original problem. So you can always check your work when you're factoring. So my factored form here is x plus 7 times x plus 2. Let's take a look at the next one. Now this guy, I'm going to use AC method. Anytime we have a number in front of the x squared term, a coefficient for x squared, and a value that's not 1, I prefer to use AC method. I think for some of us that struggled with guess and check on problems like these in Algebra 1, that AC method, it gives us a strategy, it gives us sort of a system to use other than, I don't know, 1 and 10, I guess, 2 and 5, I don't know where they go. I think that's where some of us struggled in Algebra 1. So I'm going to use AC method for today on problems like this. If you prefer guess and check, that's fine. But just remember, you do actually need to do the check part of guess and check. So if you want to set up your factors and say, I know one of them's 3x, one of them's x, I don't know what goes in the back, you have to do the check to make sure you factored correctly. Again, I'm going to use AC method here. So that is 3 times 10. A times C, that gives me 30. And I want factors of 30 that add to 17. Anybody know what factors we want here? 2 and 15, yeah. So now I'm going to rewrite this. The first term stays the same. The middle term, I'm going to rewrite as 2 different terms. So plus 2x since we had positive 2, and then plus 15x since we had positive 15. If I were to combine these, I would get back to 17x. And then the end term stays the same. The only thing that changes is the middle. I rewrite the middle split up so that I can use my grouping strategy from the other day. Okay, so anything that's 4 terms, you use grouping in here. So that's the point of this. I rewrite it so that I can factor it a way I know how to factor already. Then I look for the GCF for my first group. What's our GCF for this first group? X. What's left over when I factor out X? 3X plus 2, good. How about my second group? What's the GCF here? 5. What's left over when I factor out 5? 3X plus 2, perfect. Remember our stuff in parentheses, we always want to be the same. Another reason I like group, or I like this AC method, is because we spent some time already practicing grouping and we're just doing grouping again. It's like grouping with 1 extra step. So it's something you've already done, we've already practiced. So anyway, stuff in parentheses is the same. So that's my new GCF that I take out. And I'm left with X plus 5. Yeah. So my factored form here would be 3X plus 2 times X plus 5. Let's take a look at one more. Let's take a look at this guy here. Negative 2x squared plus 34x minus 144. What's the first thing I want to do with any factoring problem? First thing I want to look for. Look to see if there's a greatest common factor. Look for a GCF. Do I have a GCF here? 2, yeah. And since my lead coefficient is negative, I'm actually going to take out negative 2. So I'm going to factor negative 2 out of every problem. That leaves me with x squared. This would be minus 17x plus 72. Now I'm going to continue factoring this piece here. I've got 3 terms, so we can use AC method or guess and check. I'm going to opt to use guess and check on this one since the lead coefficient is just 1. Remember that negative 2 we pulled out as the GCF, so I'm just worrying about this part right here. So I want factors of 72 that would add to negative 17. This is one where you may need to make a list. Anybody know what factors we want? What did you say? 9 and 8, yeah. And to get negative 17, I want negative 9 times negative 8, right? So that they're negative. So then this would be x minus 9 times x minus 8. And don't forget your GCF. So I would have negative 2 times x minus 9 times x minus 8. Questions for me so far? Okay, let's do one more AC problem together. Let's take a look at this guy right here. So I have 5x squared minus 7x plus 2. Since I have a lead coefficient that's not 1, I'm going to use the AC method on this one. And I want you guys to see one more example of that AC method. Again, if you prefer guess and check, that's fine. I want to show you another option in case guess and check didn't work well for you in Algebra 1. So I'm going to take A and C and multiply them together. So 5 times 2, that gives us 10. I want factors of 10 that add to negative 7. Factors of 10 that add to negative 7. Five and 2, right? And to get negative 7, negative 5, and negative 2. So I'm going to rewrite this with the middle term split up. That first term stays the same, 5x squared, and then minus 5x minus 2x plus 2. The end term stays the same. The only thing I changed was that middle. I split it up using the factors that we picked. And now I'm going to use grouping since I have 4 terms. What's my GCF for the first group? 5x. What's left over when I factor out 5x? X minus 1. Good. How about for the second group? What's my GCF? 2. And since the group starts with a negative, I'm going to take -2 out. What's left when I factor out -2? Minus. Change the sign. Bless you. Okay. Now my stuff in parentheses is the same. So that's my GCF. And then I'm left with 5x minus 2. And there's my factored form. So this would be x minus 1 times 5x minus 2. Questions for me for today? Okay, so we talked about factoring out greatest common factors, which we did with this problem right here. We talked about factoring when we have 4 terms, which we saw today with our AC method, and we practiced last week as well. And then we talked about factoring these 3-term polynomials, these trinomials, using that sort of guess and check method. Okay. So the next thing we're going to do is outside. We've got some more practice. We're going to do factoring. So I will get you guys the materials you need, and we will get started with our next activity.